Okay. So what project were you thinking of doing for this DBT? I'm guessing like a robotics one would probably be good. Maybe the hexapod one.
Yeah, so I think the hexapod one would be a good idea. Perhaps with that, we want to extend it with some extra behavior. Have you got any possible behaviors you'd like to initialize for this?
Yeah, like we could do like I don't know, like a line follow or a maze solver or something.
Uh, yeah, so I feel like because of the type of robot a hexapod is, with being has three legs on the left, three legs on the right, it might be a bit too complex to implement a maze. Uh, Maybe a line follower or light follower may be more achievable.
Yeah, actually, yeah, because we did just do a neural Bratenberg, so maybe we can just adapt the hexapod to behave like a Bratenberg robot then.
It sounds like a good idea.
Yep. Okay then. So what do we need to do then to make a hexapod that follows light? What kind of things do you think we need?
Well, firstly, we should see if steering would be possible before going any further. So, how are we going to steer the robot?
Okay. Right. So the robot walks using a neural oscillator and it has delayed offsets. And because it uses a tau value for the rate of response, we should be able to use that if we can modify the tau value in some way. We should be able to affect the walking speed.
Yeah. So, in regards to the tau, I reckon that perhaps we should try increase or decrease the tau of one of the sides and see how that affects the movement of the robot.
Yep. Okay. Right. I'll give that a try then, and I'll get back to you.
All right.
Okay. So I tried doing that thing you suggested, modifying the tau values, and I've managed to get something to work by multiplying the tau by a small change. But we need to check like the range of these values because it'd be interesting to see how much we can make it turn by. Um, so the next step as well, we need to get some light sensors on the robot. So whilst I look at doing the light sensor stuff, do you mind taking a look at the range of values for me?
Yeah, that's no problem. Yeah. I'll have a look into those values for you.
Okay. Right. I've got some light sensors working on the robot now. I had to make some meshes for it because turns out in Weebots the light sensor doesn't actually have an object. You can drag it in and you can make it child of the robot, but it means you can't really see it. You can't see where it's pointing. So I put a mesh in, and we now got like a visual reference point. We can grab the mesh, move that around, and it should give us a visual reference point for where the light sensor's facing. How did your investigation into the turning go?
So it does work, but it probably could do a lot better. It's a limitation with the tau values meant that it can't exceed certain tau values, otherwise we start getting strange behavior.
Is it enough to use to test light following?
Yeah, it should be enough, but I do actually have another idea. So while I'm looking into that, uh, you get the line following to work, and then I will come back to you with an idea.
Okay, right, good news. Light following works. I had to butcher some of the code across from the Bratenberg robots. I put the light sensors in. Had some problems with the light sensors. Had to change their initialization parameters to match the expected output range for the sensor. But then it just passes it through a method. It references the raw sensor values against a lookup table and gives out a normalized value between 0 and 1. I'm using that as a multiplier to modify the tau of the robot left and right separately. And it does, it reacts to light and it steers. Although I made a bit of a mistake, I hooked the legs up and the sensors up so the left drove the left, which meant it was actually a light avoiding robot. So I just swapped those around and it worked. Yeah, it does turn, but I can see that problem you were talking about with the range of the turning.
Yeah.
Did we
Um,
discuss that last time?
Yeah, we did, yeah. I said I was going to go away and look at another idea
All
to
right.
try and counteract that.
Yeah. I mean, it's not a massive problem. But turns out if the light source is like to the immediate side of the robot, it can't turn towards it easily, but it still turns.
Yeah, as speculated. Well, I did find a workaround, as you will. I was investigating the drives. Drive L and Drive R is what we're using, and realised that you can actually adjust it on one side to control the robot to rotate on the spot.
Right.
Using a conditional statement, and this will be when the threshold is met as per usual. So I'm currently in the midst of testing that now, but essentially it's if the output conditions are swapped so that way the drive is 0 instead of 1 under certain conditions, it allows it to rotate on a certain
Right.
condition. So investigate that.
Okay. So what we can do is then instead use the light sensor values. If we compare the sensor values against each other and have it so that it starts turning when the one side is stronger than the other. Is that what we're going to
Yeah.
do? Okay,
Yes.
cool. And does it work? Does it like to switch the legs off, or do the legs like move in the opposite direction?
No, it's almost as if they reverse. So it'd be like
Right.
one side's going backwards and the other side's going forwards, which allows it to rotate on the spot. If
Oh,
it was
okay,
to
yeah.
just turn off completely, it would end up just dragging the robot. So
Okay,
thankfully, it doesn't do that. It does do the reverse.
okay. So I was thinking about the new steering method for the robot. Uh, because of the way it turns, it's capable of turning the spot. Can it only turn on the spot, or is it capable of doing it whilst driving?
Yeah, so I feel like with this, we're basically sacrificing the ability to rotate while it's moving to get it to rotate on the spot. But there is a benefit to that, obviously. So it would be more of a direct route, as you will, rather than having to arc, and it would create more distance.
Okay, so it's in a way it's more efficient because it'll just turn to face the light source and then.
Yeah, exactly.
Okay.
Um, uh, yeah, so I have tested it, and it seems to be working fine. There doesn't seem to be any issues. But there's one downside to the approach, I suppose, because we're using the values of the light sensors to start and stop turning. When both light sensors output max, both sets of legs stop.
Right.
Um, and this is the a desired stopping behavior that we'd want, but
Mm.
it seems to do it at a range that perhaps we want to get the robot a little bit closer. Um, Obviously, there is some limitation there.
Right. So because of the fact we're relying on the output of the light sensors, that if they're both at max, then it thinks it's found the light source, so it comes to a complete
Yeah,
stop. Right.
exactly.
That means then, yeah, there is a certain range then that when the robot gets close enough to light, it thinks it's found it, even if it's a certain distance away, and it will stop walking. Um,
Yeah,
I mean that should be okay. I guess if we wanted to make it walk closer, we could use like a third offset license at the rear of the robot and use it as a final control, because then you'd have like an entire length of the robot. But considering our main goal was to make a robot that kind of just followed light, I'd say we're there. I'm happy to say we achieved the desired behavior. How about you?
yeah, I'm happy with the behavior it does so far. Obviously, there are improvements we could make, but
Yeah.
be all end all, it was a good project, and I think we've done a lot of adjustments to it.
Yeah, okay. Let's finish the write up, publish the results, and get this one cracked off then. Okay,
Yeah,
cheers, Callum.
welcome.